Now, points of intersection, section 8.4, hopefully you know already facts like where does a graph cross the x-axis when y equals 0? Where does a graph cross the y-axis when x equals 0? Where do two curves meet? Take the equations and solve them simultaneously. Now, all of that stuff is still true, but we've got an extra variable involved, so things get a little bit more fiddly. So let's take this example, and I'm just going to talk through this because, in the book, I'm just going to talk through the blue box, because this is techniques that we do already know, we're just applying them slightly differently. So find the value of A in these two things, and given that it passes through the point -4, 0. In other words, it tells us where it hits the x-axis. So if it's telling us where it hits the x-axis, it's telling us information about when y equals 0. So if I put y equals 0 into this equation, it's not going to give me the value of A straight away. So what is it going to give me? Well, it's going to give me AT cubed plus 8. Now from that and that, if we look at those equations now, sorry, and I've got, when x equals -4, I get AT squared plus t. So I've got two equations from that bit of information. I've got two equations which I can solve simultaneously and find A and t. Okay, so when does it hit the x-axis? When y equals 0. Put y equal to 0 and follow through the repercussions of that in this equation, which gives me this. It happens when x equals -4, follow through the repercussions in this equation, which gives me this, and now I can look at the algebra that I've got left and solve it and find A and t. Now, they're going to give you all sorts of different examples of that sort of idea, right? So let's have a look at example 9. This meets the curve given by parametrically by this meets this line at A. In other words, this equation, and this equation can be solved simultaneously, and when you solve them simultaneously, the coordinates x and y that we get, we're calling point A. Okay, so if we take those three equations and solve them all simultaneously, well, the way they've chosen to do that in the book is to replace x with t squared, replace y with 4t, and solve that. You can find the t value. Once you've found the t value, you can use it to find the x value and the y value. Okay, so it's using information that we've already got and applying it in this new context. The information that I'm talking about, just to hammer the point home, is it hits the x-axis when y equals 0. It's the y-axis when x equals 0. A curve and a line meet, or two curves meet, when you can solve their equations simultaneously. All of that is still true. The solving simultaneously might be a bit fiddly. The put y equal to 0 and follow the repercussions through might be a bit more fiddly, because now we've got more equations to have to sort of follow through. You might have to find a t value first and all the rest of it. But if you know the value of t, then you can find the value of x and the value of y, because you've got parametric equations. If you know the value of x, you can find the value of t, and from the value of t, you can find the value of y, because that's what the parametric equations do for us. So that's exercise 8D and section 8.4.